Yeah. Okay. If you just came in, guys, I checked homework, so can you show me last night's homework? And before school, someone asked about number 21, so it's up here. And the catch with 21, first of all, as I told you, AP will not ask you about arcsecant and its derivative, but it is the only one that's in your textbook to show you an arc trig as integration by parts, so I put one in there. And I wanted to also point out that going from the green to the pink here, it started as an integration by parts problem, and then the second piece turned into just U substitution. So within a single problem, you might need to change gears. So it's up there. You do last night's?
No.
Okay. See?
I already did my homework.
Okay. So, and just the secant inverse derivative, secant sucks, so it's got that absolute value of theta. Secant begins with s, so there's a square root, a squared, and a subtract. You did not learn it first for the ones in the back, but again, you don't need to remember this one so much. Absolute value bars. In the problem, it says theta is greater than 1, so it's already positive, so I can get rid of those absolute value bars. And in the acronym, log, don't have log. Next one, choosing the U value, inverse trig, that's my U value. So dV is the rest of the stuff, which is theta d theta. Integrate, do the derivative, put the pieces together. And we get here.
What?
uv minus the integral of v du. And then it's just regular U substitution. The stuff under the square root is our U value. And swapping things out, let's see. So theta squared minus 1, derivative is 2. I solved for theta d theta and put it in as 1/2 du. Why did I write 1/4? Because the half is already there. So it's another 2 underneath. Integrating this, it is not natural log. Raise the power from -1/2 to a +1/2. And then dividing by 1/2 is the same as multiplying by 2, so the 4 turned back into a 2. And then substituting back the theta values, and don't forget plus C. Yeah.
Where did the d theta come from when you went green pink?
Where did this d theta come from? Should have been there. Sorry. Yes.
So when you're doing this, do you have, like, is there another?
There's not really another way.
I don't know.
Okay. And number 9 is also one of those that's integration by parts where it's different than. You okay?
I'm fine.
Do we need to do number 9 or are you good? The natural log is the U value. And the cool thing about natural log is its derivative is 1/x, cancels with some of those x cubes or x to the 4ths, and things shake out nicely, and it's a regular U substitution after that. So no other questions on these guys?
When did we learn the derivative of, when did we learn the integral of secant squared theta?
We didn't.
The integral of secant, the inverse secant.
we learned the derivative of it, and by doing the integration by parts like we did just here, we were able to integrate that with it being multiplied by theta. If it's not multiplied by theta, I don't know how to do it. I did also want to show that
I'd like to memorize everything.
well, it's unfortunate if you have to memorize everything because you kind of need some understanding. Okay. I need to show you these. So write them down with a pencil into the notebook. Yeah, thank you. Believe it or not, you do know how to do these. It's just hidden. Does the first one look like anything that we know? Can we do any changes to it? Josh, you see something?
Can take out 5/9.
Yes. Okay, so Josh says if we take out the 5 from the numerator and factor out a 9 from the denominator, he said it looks like arctan. More than it looks like arctan, it is arctan. AP exam loves this one, loves it a lot. So you might need to do some tricky business. But was that one reasonable?
Yeah.
Second one's harder.
Okay, so
Do you see something?
Looks like a circle, but it's like the denominator.
Circle, but it's in the denominator, so I don't know what the heck that is. But you're right. I mean, yeah.
semicircle?
But it's in the denominator, so I don't know what that looks like. Sasha, any idea? People are tapping out. All right. Secant. Secant needs the thing in the front.
Oh, yeah.
Jail bars, yeah. Okay, so U substitution's not gonna work, because I need a X up top. Okay. If I factor 16 out of both of those terms, this is a 1. What happens to the second term? 1/16 times x squared. Okay. Okay. X squared over 16 is what thing squared?
X over 4.
X over 4. Square roots, are you guys okay that I took a single square root and broke it into 2? That's legal?
Yeah.
Okay. Square root of 16 is
4.
4. Do I have to put a plus or minus? Camden, why not?
Because there's no minus sign. Square root.
The square root was given to you, the sign was there in front of it, it's not written. When it's positive, I don't need to write it, but it's right, you don't need to do that. So I'm gonna do what Josh did over there, and I'm gonna take the coefficients out because they piss me off. And I am left with 1 over square root of 1 minus that stuff squared. It's still kind of hidden, but does this look familiar? What? Do you see something?
Arc side.
Arc sine. And secant you don't need to know, but arc sine and arc tangent you do. Tangent, not begin with an S, but the little plus sign looks like the T. It's got a squared in it. Sine begins with S. There's a squared, a squared, a squared, a square root, a subtract. You learn sine first, so the one goes up front. So this is 3/4 arc sine of stuff divided by the derivative of stuff. What's the derivative of stuff? 1/4, but I'm dividing by 1/4, which is really multiplying by 4. So it's 3 arc sine x over 4 plus c. You will see this on AP. One of these flavors. Yeah.
Do we know arc cosine?
Arc cosine. There you go. Here's arc cosine. Because they made it negative. So arc cotangent is just arctan with a negative on it. So no, you can get away without knowing it. So I needed to show you tricky. Ari, reasonable? Okay. And the question on the quiz that's the highest point count is initial value problems. Can you guys do this one? And then we'll hopefully have time to get to questions from this.
So the integral of y, so like looks like dy dx by.
Okay, write it down, just try it. And these are the ones on the AP exam that are worth usually 5 points. And the rubric says 0 out of 5 if you do not do the first step, which is separate the variables, y's with y's, x's with x's.
Yeah, I have a question. I forget who multiplied by 4 instead of dividing by 4.
We were dividing by 1/4,
Oh, okay.
which is multiplying by 4.
Yeah, okay.
So I'm multiplying.
Wait, I have a question. If I move C to the other side and subtract it, do I write minus or should I plus?
So I would put the C on this
On
one.
that side?
But it doesn't
What if
matter.
I didn't, and I did subtract it? Is that fine? Is it minus C?
Sure.
Okay,
Then
I'm not sure.
if she solves for C and had it on the other side and she got +3, you're gonna get a -3. So
Okay, so then you're gonna move it.
you should get the same end answer.
Got it, thank you.
Did I do that right?
Wait, did you flip that?
Okay, no, so that's why I left the pink, I'm not done.
Weird. What?
Okay, raise the power, divide by the new power for the y side,
Okay.
yeah. And then whose derivative is positive cosine, positive sine, and remember to divide by the derivative of the stuff inside. And I multiplied, when I went to the green here, I multiplied by 2. I did not double the plus c because it's still an unknown pile of stuff. Right here, I put an asterisk right there. I am plugging in my initial value. So now if I do anything, I do need to distribute the 2. I do need to do whatever to that c value also. And note, I need to remember my new circle. Sine of pi over 6 is a half.
So you don't need to affect the C whatsoever.
Well, now, right here, Amir, once I plug these x and y values in,
Like when you're doing the transformation of Y. Like,
Okay. Up here,
You're multiplying it by 2.
and I didn't have to distribute it to the c because it's still unknown. But Amir, the difference is right at this step.
Okay.
I am now plugging in x and y, so c is fixed, and I need to do all
Okay,
of
so
my
only
numbers.
when you're not, like only when you're done doing the what was it called? When you're
So Amir, it's your choice. It's when you plug in the coordinate that it's fixed.
done adjusting the equation.
Yes. All right, so then I put in the square root versus the one that I asked Camden about earlier. The square root was already there, and he's like, it's positive because it's already given. I put in the square root, so I needed to do plus or minus. I only want the single solution. All right, what's your question or comment?
I would say it should just be minus because, because you can't have a negative square root and all that. It has to be minus on the outside because the y is negative 2.
Okay, so it has to be minus because it needs to match the initial value that I was given. And the only way to get a negative y is to force that square root to be the negative branch. That wrinkle is on the AP exam every 2 or 3 years. It's due. So I needed to point that wrinkle out too. Yeah.
So if the y value was positive, then we'll just square root it again.
Yeah, all right, so if the initial value I gave you was positive 2, like, you can tell it's gonna be a problem, because when I plugged that negative 2 in, it became a positive, so, like, I get ticked off when I'm doing natural log and it's absolute value, and I needed to do the absolute value, make that negative a positive, that's a warning that you're probably gonna have to do something with that. Okay? Yeah. And so 1 point for separating the variables, 1 point for integrating correctly. If you forget plus c, you get no more points. Then solving for y and finding the c value, those are each a point in themselves. And then getting the final answer and realizing to choose the positive branch or the negative branch correctly. Cool?
I don't know if this matters, but what if the y value is positive and then the x value is negative in this case? How would that change?
If the x value was negative, then this would have been a negative half, and then it would have changed our c value. I mean, you just use the value as it is, and then go through and look to see what gives you what final equation gives you your initial value.
So do you just match it to the sign of the y value?
Yeah.
Okay.
I think I have one more with the weird wrinkle. Yes.
I just wonder if the X value affected it.
So now that you've seen that, try this one, and then we'll go over whatever you guys have questions on.
No, but since they're absolute value bars. That's gross.
Massimo, if I say the absolute value of A equals 3, what are the two possible values that A could be?
3 and negative 3.
So A is either positive 3 or negative 3. All right. So in doing this initial value problem, it's another one that could be one that I need to do some trick to. Separate the variables, integrating 1 over y, I get natural log, and I need to put the absolute value in. The other side's simple little polynomial, raise the power divided by the new power. Plug in C, C is ugly. Oh well. I need to get y out, so I'm gonna do e to both sides, and science-focused people, you're gonna have to be comfortable with this. I split this up, e to the x cubed plus 8, and then e to the natural log of 3 is just 3. And just as Massimo did the absolute value of y, it's either the positive or the negative of this. Which one, if plugging in, gives me my initial value? The negative. And these two examples, I put them here to point that one little fact out. Often it's going to be the positive one, and you're going to forget that you should check. And you might slide under the radar and it might be okay. But if it's the negative branch, they're gonna get you. And I'm feeling it's good. Just for you, Alex, just for you. Okay. So I showed you the special tan inverse wrinkle, sine inverse wrinkle of factoring stuff out of that square root, and you might need to look for things. Integration by parts, that on the second step it didn't stay as integration by parts, but turned into u substitution of some form. And the initial value problems where that you might need to choose the right branch. All right. Whew. Lots of stuff. Yeah. This is one of the questions from the sample quiz. I did not go over integration by parts, which this is integration by parts the whole way. You could do it as tabular, I don't care. It's one step in tabular. But it has bounds on it. So I did not show you how to evaluate those. But once you get it integrated, you plug the top number into everybody, minus plug the bottom number into everybody, and evaluate. Yes?
Did the bounds not change for this problem? Like as opposed to some like u substitution that we put?
Okay. Did I ever put u in?
No, so you didn't like translate it to
I didn't translate it to x's. I used the u and the v to get the setup of this pattern, but they're still all x's, so the bounds are still all x's. But good point. So on u substitution, you do, and if there's a definite integral, you do need to change the bounds so it's correct in mid-process. Issues, comments, questions?
Wait, what do you say about the bounds? You do change them.
Okay, so I asked Sophie, she's like, but we used u and v in my integration step. Are these terms in terms of x, or are they in terms of u and v?
X.
They're x's. So I used these patterns to get an idea of how to set up the u times v minus the integral of u prod, v u prod. But I didn't change the x's to u's. Yes.
So, can you explain how you got the red that's right above?
Okay, how do I get to the red in the first place? All right. Looking at the problem, I really want to use u substitution because that's the nicest way to deal with products, but it doesn't work. I can't choose a u value that the derivative of that thing is going to be there. So it's going to be a product that's integration by parts, and I need to figure this, choosing what's the u value, what's the v value. Sorry. Doesn't matter which way they go, but the acronym doesn't work otherwise. So the u value is 3x, and the rest of the stuff is dv. Are you okay with that setup? Okay, then the derivative of u is 3, the integral of cosine is sine. So putting the pattern together, UV gives me this piece minus the integral of VDU. Then the integral of 3 sine is negative cosine, but it was negative, so it became positive.
Got it.
And then plugging in pi, 3 times sine of pi, well, sine of pi is 0. 3 times cosine of pi, which cosine of pi is negative 1, minus all this stuff with pi over 2 plugged in.
I'm just confused about the straight bar.
This bit is integrated. So I need to evaluate that integrated piece at the bounds. Like, all right. Here, if I integrate, raise the power divided by the new power, it's now integrated. This stuff was integrated. Plug in the top number minus plug in the bottom number. So that's, instead of doing it here and then integrating this and then doing it again with the P, I just got the answer. Woo! Oh. Got the whole thing and then plugged it. And you're still not happy with it.
Okay, I think I'm just confused on how, like, it's two separate parts and then, like, can you just combine them since they're bounded?
Once it's fully integrated, I have all of the function integrated. Plus 3. So plugging in 4, 16 plus 12, I plug into both pieces, minus 0 plus 0. Like, you can do it in pieces or you can do it all together. It's your choice, whatever you like.
So is it like, when you have the integration symbol, how if there are two parts with the same amount added together, how you can combine them? Is that the same with like the straight bar?
The straight bar means plug in.
Yeah.
The curly Q bar means you haven't finished yet.
Okay, sorry. Going from red to blue, if red was integrated and had the bar, then you could combine both pieces into one.
If they were both already integrated, but they aren't both integrated until we get to the blue.
Okay.
This piece was not integrated yet.
Uh-huh.
Okay, we'll work on it.
I'm sorry.
Yes,
Could you not do tabular for it?
yes, you could.
Okay.
And then you need to take the answer that you got from tabular, which would have been the blue, and plug the numbers in. Okay, did you guys have questions on the 3 practice quizzes? Anything, you had something on number 3?
Yeah, I had it like on my phone, but basically there was one question where you ended up having, like, okay, it was 6, I think. It was 6 on practice B, so, or like the practice quiz B, so it would be number 2. So I ended up having like cotangent is you like or like cosecant squared, like once you integrated it. Dy, you had to integrate cosecant squared y dy and integrate like negative 2x dx. And then that ended up being cotangent. It was negative cotangent, and you divided a negative 1 on both sides, so then my answer looked different when I did it. And like the thing on the answer too.
So sitting here, I'm gonna integrate one part and not the other. The integral of this, raise the power, divide by the new power. And Sophie talked us through this. She divided by sine squared y. Sine squared is, dividing by sine squared is cosecant squared, and I moved the negative over. Whose derivative is negative cosecant squared?
Positive cotangent.
Positive cotangent. which is just gross. Then, did you solve for the C value at this point?
Yeah, somehow the way that you did it with you took the negative out and you moved it to the other. Did you divide by -1 to begin with, or how did you end up getting positive 2x dx? You integrated it.
Well, right here, I moved the negative to this side so that I could have that negative cosecant squared.
That would have fixed the issue. And then in this one, whoever like solved it, I'm guessing it was you or whatever, like didn't do that, and then I think you divided by -1.
Okay, well, let's see.
Okay.
Let's just do
I
the
was just
problem.
curious, 'cause-
Cotangent is x over y, so cotangent of pi over 2 is 0 equals 4 plus c. So c is -4. Plugged in here. So I'm going to put the -4 back in. Cotangent y is x squared minus 4.
So it's y equals r cotangent of x squared.
And is that not what's on the key?
And it's just slightly different with like the starting it. Like I think basically what I ended up getting was y equals negative arc cotangent of x squared, or 4 minus x squared.
Okay.
Is that still right?
Probably. I need to look, but I understand the process that you did.
Okay.
And I think so. Yeah, so there's ways to get things that look different. But I want to point out the quiz as it's written right now does look a slight bit different than these guys, but there are 7 questions, not 6. But you will definitely see one that it's a definite integral that you need to plug numbers in. You will probably see something that's got trig in it. You will see something that's got integration by parts or tabular. You might see trig inverse. You might see things that are divide and conquer that is not on this one. By divide and conquer, I mean maybe I made this 3x squared minus 1 over this. Can't solve that one, but there, now it's solvable. So splitting this up, this would be u substitution for the one on the left and arc what? Sine on the right. This one is u substitution, and then the initial value problems, anything goes. You need to separate the variables to get the first point. You need to be able to integrate both sides for another 1 or 2 points. Don't forget the plus c, because if you forget the plus c, you've thrown away the other 3 or 4 points of the problem. Definite integral and u substitution. Integration by parts, regular u substitution, trig, regular power rule, and arc trig, and then an initial value problem. Yeah.
Can you do number 5 on practice quiz 3?
Practice quiz 3 is the hardest one. Number 5? No, just kidding. Okay, what's the u value? Looks like u substitution. My hint is always, hey, it's the thing being raised to the power. Well, crap, they're both being raised to the power. Is one of them the other guy's derivative? Sophie says yes, Luke says yes, Oleg says yes. So Ari, which one is my u value? Okay. Gus, what is the derivative of cotangent 3x?
1/3 cosine squared. Cosine squared 3x.
Negative. The ones that begin with C are negative. Okay. So cotangent 3x is the u value. All right? U to the fifth. Cosecant squared 3x. Cosecant squared 3x is negative 3 du. All right? Now I need to change the bounds. I need to translate the x values to u values. So when x is pi over 6, u is cotangent of 3 times pi over 6, which is pi over 2. Cotangent of pi over 2. Oh, sorry, yeah.
I think I said the derivative, it's negative 3 cosecant squared.
Because doing the derivative, multiply by the power of the stuff. So du is 1/3. Better? Okay. Cotangent of pi over 2. It's x over y, so it's 0. When x is pi over 12, u is cotangent of pi over 4. Cotangent of pi over 4, 1. Raise the power, divide by the new power, and evaluate at the bounds that we translated. So plugging in 0, I get 0 minus negative 1 over 18.
Can you also like make it cosine over sine and then?
Yes, absolutely. If you don't, yes.
Okay.
So you can split things into cosine and sine and go from there. Yes.
That's what it is. Other than the quiz, yes, quiz. Are other than like an arc sine, are there any other like
Weird derivative patterns. You need to know arcsine and arctangent. And like these practice quizzes they all have something different and evil about them. This is a divide and conquer. This is do you know how to split the exponent? And then e to the natural log of x. Do you know that that's just x and it really becomes much easier? This one, just raise the power, divide by the new power, divide by the derivative of the stuff inside. You could use substitution with number 1. That one, I can see through it and I can just get the answer. So some of the things you might not need to show any work at all. This one, God, it's really mad at you. That one's what is that one? Is it use substitution, integration by parts, divide and conquer? What is it? Chase your tail. So that you need to necessarily do integration by parts twice, add the stuff to the other side, and that the number on this is negative, like that one's just me. Yay. Use substitution with trig where you needed to evaluate the bounds. Yeah, number 3, this one sucked. These are largely reasonable. All right, so anyway, tomorrow is like anything. Should I make an optional go to math?
Yes.
All right.